Hello everyone, in today's lesson, we'll do a summary for the vectors in two dimensions. Okay, let's look at the summary. Okay, the first one we'll talk about the definitions of the vectors. Definition of a vector. Okay, just look at it here. So basically, a vector is a quantity which have both magnitude and direction. So this is the key. Okay, so a vector have one direction and the magnitude. They have these two atoms, right? Okay, so which is different from the scalar. Okay, scalar only have what? Only have the magnitude. Okay, so that is the difference, right? Okay, we already gave some examples in our previous lesson. Okay, and then also the second thing we talk about is what? The second thing we talk about translations, right? We talk about translations. Okay, the translation from point A to point B is denoted by a vector A to B. So we have line. So we have A to B. Okay, so basically we talk about translation. So then we have vector A and B. So we have 2 points, right? Point A and point B, right? Okay, so we can write this vector as AB, or we can write this A. Okay, sometimes we put this. Okay, so in this case, and then it's represented by a directed line segments as short as this. Okay, so this is the line here, right? Okay, so the next one we talk about magnitude. Okay, so what's the magnitude? Right? Magnitude we can just express as 1AB, right? So here we have put the 2 points, right? So then from here we know that AB. So AB magnitude is actually the length of AB. So just look at here. So we can see from here. And a zero vector, zero is a vector, those magnitude is zero. So they have no direction. Okay, so AA or also we talk about a zero vector. So zero vector has no direction. Okay, and then it's also the magnitude is zero. Okay, so everything is zero, right? Okay, if we find this one, we see that it's a zero. It's a point. Okay, they also can sometimes express it in this way, right? Okay, this is very clear. This is the definition of the vector. Okay, and now after that, we also talk about the column. After that, we also talk about the column vector, right? The column vector. So how to express a column vector? So a column vector normally we will express in this way, x and y, right? So and then what is the magnitude? Magnitude equals to plus y, right? So we can find out magnitude, right? So and then from here, so we also learn about the additions of vectors, subtraction and multiplication of the vectors, right? Okay, so if we know that, okay, so we also learn this. For example, we have these two columns, so we can add them together, right? We can add them together, right? So if we have a subtraction, subtract the two vectors each other, right? So we also get x1 minus x2 and the y1 minus y2, right? This is subtraction, right? Okay. So in terms of multiplication, so basically if we have a k x1 and y1, so we can write in the k x1 and the k y1, right? So we already know this tree, right? 1, 2, 3, right? Okay. Next one. Okay, so this is the column vectors. Okay, next one. Okay, next one we're going to talk about the addition of the vectors. Okay, so how we do that? So basically we learn two laws, right? Two very important laws. The first is triangle law. Triangle law, which we use very frequently. Almost all of our questions we use that. Second one is a parallelogram law, right? So we also use the parallelogram law. So just look at here. So basically, if we have this, okay, and then we have this 9, okay. For example, we have this parallel, we have this. Okay, so we also can know, right? A, B, C, D, right? So from here we know, right? Look at here also. From triangle law, we know that A, B equals to what? B, A, B. You know that AB plus BC equals to what? AC, right? So this is triangle law, right? This is triangle law. The other one we also know that. Okay, so parallelogram law, AB plus AD, right? AB plus AD equals to AC, right? So that is two very important law. Okay, so that is what we learned in the previous lesson, right? Okay, let's continue. Okay, the next one what do we learn? Next one we learn the subtraction of vectors, right? Subtraction of vectors. So what do we learn? Okay, so basically if we have this, okay, we have this line. So we have A, we have B, we have D, right? So we also can come on this point here. This is C, right? So okay, so for example, if this is the V, this is U, okay, and then what do we get? AB minus AD equals to what? Okay, remember we learned that. Okay, so V equals to the DB, right? So this is what we learned, right? Okay, and then we also can come up the U minus V equals to the U plus bracket V minus the sign, right? Okay, this is how we learn in the subtractions of vectors. Okay, let's continue. Okay, so we also learn what? Okay, the next one, what do we learn? We learn the scalar multiplication of vectors, right? So the first one, so on k is more than 0, so what we get? So a and k times a is a vector, right? Ka, so they have the same direction, okay? And then of course the k magnitude equals to k times the in terms of magnitudes, they are also same, right? We can write it this way. The second one is when k is less than 0. So what do we get? So what we get is that a and the ka is in the opposite direction. So and then is the magnitude equals to minus k times a magnitude. Okay. So this is what we learned in the scalar multiplication of the vectors, right? Okay. Let's continue. The next one, what do we learn? We learn the position vectors, right? So we learn the position vectors. So if we have the OP is the position vectors of the point P with reference to a fixed point. So what's the fixed point? The fixed point is is a 0 origin, so usually it is so basically we can write in the P, and then we also can come out with a PQ equals to OQ minus OP, right? We already discussed in the previous lesson, right? So, and basically OP also can be reference to the origin point, right, in the Cartesian plan, right? So basically we can write in column vectors as X and Y. Right, so this is the thing we will discuss. Okay, so in the last, okay, let's continue. Okay, the next one, what we talk? The last one we talk about is the application of vectors in the geometry. Right, so we learn those geometries, and then a very important concept is this. Okay, so we learn a very important concept. So if we have, so if, let's move on this, in the geometry. Okay, so if we know AB equals to CD, then what do we know? We'll know what? The 2, okay? AB is parallel to CD, and then in terms of magnitude, these two lines also equals to each other, right? This is a very important concept we learned from previously, right? So, and also, if there's a K, okay, so if the AB equals to K times AC, right? So basically AB equals to when K is more than 0, so AB basically is equals to K times AC, right? Okay. So when K is less than 0, so what do we get? So AB, in fact, in terms of length, in terms of the magnitude, right? In terms of magnitude, so that will be minus K times AC, right? So that is all the length is magnitude. Okay, so basically all those things we already discussed in the previously. So that is we will find out. Okay, of course. So that is the summary of this chapter 5, vectors in 2 dimensions. Okay, that's all. How many points we discussed? 1, 2, 3, 4, 5, 6, 7. Okay, 7 points we discussed. Alright, thanks for watching. Thanks, I'll see you soon in the next video. Thank you, bye.